about delegation at the end of our protocols lesson yesterday. We said delegation is a pattern in iOS development that enables one object to listen to changes from a different object, right? So yesterday we saw an example of that at the end of the lesson. All right, we also saw an example in our lab where you had a heart rate monitor monitoring for heart rate changes, and the view controller updated its label. Yes, we were not able to see that label on a UI, but behind the scenes, that's what happened. So the heart rate class got initiated, and the view controller registered as a delegate to listen for changes from that heart rate receiver. Everybody? Right? So that's basically the delegation pattern. How can I get notifications from object A if I'm object B? Right? I'm disconnected from object A, I'm object B. How do I get notified of changes? Right? How do I know somebody got to the door? How do I know somebody opened the door? How do I get those notifications? So yesterday we got introduced to the delegation pattern via protocols. We created our own protocol yesterday, and we created a delegate variable in the class we wanted to get notified from, and the class that was getting notified was the view controller. The view controller registered to get notifications from that delegate, okay? That is the delegation pattern. In iOS development, there's various ways to find out notifications from an object. Today, or yesterday and today, we'll be using the delegation pattern. Other patterns we have in iOS development, we have KVO, which is key value observing. We also have notification center, okay? We'll address those later into the program, but for now, especially as we head into week 2, week 3, where we start talking about UI table view controller, we need to get used to the delegation pattern, because both UI table view controller and, as today we'll see, UITextField has a delegate. How do I know that the user clicked on the done button on my keyboard? How do I get notified about that? So today we'll start seeing that via UITextField, okay? So that's what we'll be doing today. Again, some vocabulary to know. What is a delegate? It's a pattern in iOS where one object registers to get notifications from a different object. We spoke about that yesterday. We saw some examples there. Delegation refresher. Yesterday we had protocols. We created various protocols. We also created our own protocols yesterday. And we know that a protocol by definition, a protocol is a template or a blueprint that lists requirements that the conforming object needs to implement. Example, here we have a protocol called cook, right? It has one function, one required function called making food. The struct called parent conforms, right? Conforms means it agrees to implement the requirements of the cook protocol. So it conforms to cook protocol. That means it needs to implement making food. And we saw that protocols cannot implement methods. They only list what the method is. The method could have a return type. It could have arguments. In that case, making food doesn't have a return type. It doesn't have any arguments, right? So here, parent implemented making food, and making food simply prints out pizza coming soon, right? So that's making use of a protocol. And we said one benefit of protocol-oriented programming, you'll hear that thrown around, right? Over object-oriented programming, meaning you have a class that inherits from another class. That in iOS, you could only have single inheritance. One class could only inherit once from a next class, okay? There's no multiple inheritance from a class. But with protocol, you could basically take functionality from a varied amount of protocols. As we saw yesterday, we had a protocol called person. Person conformed to fully named. It also conformed to equatable, right? And it also conformed to CustomStringConvertible. So that one struct we had yesterday was able to have multiple conformance to multiple protocols, right? So that's one of the huge benefits of protocols. Any questions? Anna, what does CustomStringConvertible do? We can look it up. So the question was, what does CustomStringConvertible protocol give us? What does it give us on our object? I'll give Anna a couple seconds and then we'll get to it. So a simple Google search, CustomStringConvertible Swift should get us to the class, right? So if we go to our browser and we type in CustomStringConvertible, we'll come up with CustomStringConvertible from the Swift standard library. And basically, as somebody pointed out, I think that was Eric, right? Eric said it gives us access to a description instance here. So that description, every object has a description. That's why we could say print my object, and some description gets printed out. So far, so good, right? Yulia, what does that mean when I say print object and description gets printed out? The description of the object. What does that mean to you? Right, and if we want to override, that description, we conform to CustomStringConvertible. Right? Questions as to why we conform to CustomStringConvertible? Yes, sir. Yes, readable or also have your own custom string printed out. Readable is one thing, but you might want your object to be printed out in such a way that's more your intention of how it should be printed out, right? In the example that you see on the Swift documentation here, they created, can everybody see in the back? Can everybody see in the back? Okay, so here we on the CustomStringConvertible page, right? The API documentation for CustomStringConvertible. And here it says a type with a customized textual representation, right? So basically it gives you freedom to customize what description is. So when I say print my object, whatever I override the description with, that's what gets printed out, okay? In the example on the Swift page, again, it's a protocol here. Type, it's a protocol. We have a struct. It's called point. We all see that, right? So we have a struct, it's called point. We have two properties. We have an X and a Y. Both of them are ints. Do we see that? Great. Then we created an instance. Here. We said let P equal to point, X is 21, Y is 30, right? And we said print P, print my object. When I say print my object, I'm talking about the instance there. Print what my instance is. Since we haven't done any CustomStringConvertible conformance, it prints the description of the object, the default description. In that case, the default description prints out the name of the object. What's the name of the object? Point, right? So the name of the object is point, and it basically uses some sort of function signature or initialization syntax to show what X is. X colon 21, comma, Y colon 30. Those are the values of my point. Everybody see that, right? So if we were to print that out, that's what it is. If we want to go one step further, we want to have our own description. We do not want print point to come up. We want our own custom description, right? We go ahead and we conform. Right now, point is conforming to CustomStringConvertible. Do we see that on the screen? Right? So now I conform to CustomStringConvertible. I'm required, the minute I conform to CustomStringConvertible, I am required to go ahead and implement description, right? So I need to implement description. it returns a string. This here is a computed property. It simply returns, it's a get only property. It simply returns the valuation. Whatever I decided to return the string, I have to return a string. That's all I have to do. I have to return a string. As to what the string is, it's up to me. Here we decided, or the documentation decided, to simply say what X is, use string interpolation, X comma Y. Do we see that? So no longer will it say point, it will just say X comma Y. So when we go down to print P, it no longer does this print. Now it does this simple print here with the quotations. Do we see that? So that's what CustomStringConvertible gives us. It gives us access to the default description on every object. Yes, go ahead.
Let's say that you couldn't do print p dot x comma p dot y.
Yeah, you could print the properties by itself. That's fine.
But you specifically want to print where
Yeah, well, you only want to just print the entire object. You could print individual properties. I could say print p.x, p.y. You could also do that, but that's extra work, correct? You have to do that many other places. But now that's only one place in your code. Assuming you have 5 view controllers or 5 views, you have to do that p dot. One place you might make a mistake, you might have a bug, right? Now you have that throughout the object. So any place I could say print p. Anywhere in my code base I could say print p. In any file. Everybody with me? We'll see what extensions look like today. We'll use extensions when we use our UITextField delegate. But for now, we'll talk about extension more into the lecture. But yes, you could do p.x, p.y, but you're doing that everywhere you want to do it, right? As opposed to saying, hey, simply, I want anywhere I say print my object, I want x comma y to happen. Cool? Very good. All right, so that is an overview of a built-in protocol here, CustomStringConvertible. Any questions from what we did yesterday? Okay, great. So going back to our lesson here, we'll kick off our delegation pattern. Again, that's one of the patterns in iOS. You will get asked that question at some point in your interview, right? If you get it like a phone screen, most likely they'll ask you, can you name me some design patterns or ways we could listen to other objects in iOS? Delegation pattern is one of the ways, right? And it's heavily, heavily used in UIKit. UIKit is heavily makes use of the delegation pattern, right? Great. So here we are using TextField today. We haven't gotten user input from iOS yet, so today we'll start getting user input from the user. And a TextField element allows us to do that. Properties of a text field, right? The text field has text, and text is the string that the text field has. That's how you access the text on it. You could change the color of the text. That text color will change the color. The font you could also change, alignment, placeholder. There's a lot of properties on a text field you could change, right? Those are some of the properties here. You could make your text field capitalized, all the characters capitalized. You could make it autocorrect. One of the things, if you have a password field, for example, in your password field, you do not want the user to have autocorrect in that field. That might be a bit annoying, right? So you want to turn that off. We'll see ways to do that. There's spell check, also one of the things you might want to turn off if you're doing password validation there. The return key, the appearance, all that you could modify in Interface Builder or in code, right? So today we'll kick off with a demo to show us how to use UITextField and how to use UITextField delegate. So we'll kick off and we'll create an Xcode project. We'll call the Xcode project Guessing Game. It's going to be a single view application. We're using storyboards. So let's go to Xcode. So Xcode single view app, click next. And for the name, we're calling it guessing game. Great. Click next. I will save it on my desktop. Great. Okay, let's go to storyboard. Everybody's created the project, correct? It's called Guessing Game. Let's maneuver, let's navigate to storyboard. Okay, so in storyboard, we have one view. For now, we'll have one view until next week where we'll have multiple view controllers. Right, so for now, we have one view. Let's go ahead and drag in a label. Get access to the library, Shift Command L, drag in a label. I'll position the label close to the top here. I will make my label longer by dragging the left side to the left guideline. I'll drag the right side to the right guideline. And my label is basically instructions. So here I will say, guess a number between 18 to 21. So that's my instructions label. Let's get back to the object library. So Command Shift L, and let's search for TextField. Right? So we have TextField. That's one way the user could enter input. We also have a text view, but for today, we'll talk about TextField. So let's go ahead and drag a TextField in. I'll position it right below my blue guideline here. So just position it right about where the blue guideline is for the bottom of the label. And also make your text field longer by dragging the right side to the right margin guideline, drag the left side to the left blue guideline there. Great. So that's the first time we're seeing a UI text field today. Let's go to Attributes Inspector and see what we could change on our text field. So make sure your text field is selected, and Attributes Inspector. So I'm in the Attributes Inspector for my text field, right? So it should be saying text field here. Great. And text field is a control. It inherits from control. Control inherits from UI view. So very similar to a button, a text field is also a UI control. One thing we could do on our text field, because right now, actually, let's go ahead and launch the application. So build your application on an iPhone 11 Pro Max. Make sure your view as is the same. So for your view as, select iPhone 11 Pro Max. Go ahead, Command R to run your application. Right, so here oh no, sorry, that wasn't the simulator. My simulator is still loading. Okay, so our simulator loaded, all our simulators loaded, correct? All right, so our simulator loaded and we see our label, great. We see our text field, awesome. if you click in the text field, does your keyboard come up? Everybody, keyboard came up? One way to toggle the keyboard, when I say toggle, by now we know it's to switch it on or off, correct? Make it show or make it hide, right? When I say toggle. So one way to toggle the keyboard, make sure you click inside of the text field. So click inside of the text field and Shift Command K, K for keyboard, Shift Command K. Shift Command K brings up the keyboard. Shift Command K hides the keyboard. Everybody? Right? So here I could enter text into my key, into my text field here. Right? Great? Right? So there's also autocorrect by default. So here, do we see autocorrect by default as well? Right? So if you try to spell a word wrong, it's going to autocorrect it. Great, so that's our UITextField. It enables us to enter input, user input. But one thing the text field could have, it could let the user know what to do, right? Like we could add in a placeholder, right? Like enter text here or something. You could give like a placeholder on the text field. So let's go ahead and add some placeholder text. So click on your text field, on your scene, click on your text field, go back to the attributes inspector. Do we see where it says placeholder here? Do we see placeholder? Okay, so you could click on the placeholder and put in some placeholder text, like enter or enter a guess, for example. Enter your guess. And press enter. Right? When you press enter, it commits, and now your scene should have been updated. Did our scene update? Run the app again, Command R. Right, so here we have enter your guess. As the user starts typing, the placeholder goes away. If the user clears the text field, the placeholder comes back. We were able to test that correctly? Okay, perfect. All right, couple things we could change. Let's go back to our attributes inspector here. We could change the capitalization. Right now, it's none. We could make everything capitalized. We could capitalize sentences, all characters, only words. Those are things we could do as well. Other things we could do, correction. By default, correction is on, right? For our guest, our guest app we're making, change default to no. So our correction is going to be no here. So correction should say no. Everybody, right? There's a lot of things we could change. We could change the keyboard type, right? Like, do you want the user to only have access to a decimal keyboard or a phone pad, right? There's a lot of customization there with the keyboard type. Like, what type of keyboard do you want? If we change it to, say, numbers and punctuation, go ahead and change keyboard type. So make sure keyboard type here. Change that to numbers and punctuation. You could even change the return key, what the return key looks like, right? So a lot of customization on the UITextField. Let's go again and test. Run your application again. Great, let's start typing in. Autocorrect should be off. Now we have a new keyboard. Do we see the keyboard? Right, before we had an alphanumeric keyboard. Now we have numbers and punctuation. Everybody? All right, excellent. Let's go ahead and add a button below our text field. So we'll add a button below our text field. And we'll call the button, or we'll name the button Submit Guess. So go ahead, access your library, get a button, a UI button. Get a UI button here. And I'll position my UI button right below my text field. And I'll simply change the title to say Submit submit guest. And I'll drag a label, or I could option drag. We want a label below our button, so you could go ahead and option drag. So option drag a label below your submit guest. And this one will simply be the result. This one will be the result of guess for now. We want to center our text. We want to align our text center. So for our text, our label, we'll click on the label. Right now it's left aligned. I want it to be center aligned. So I'll click on my label. I'll go to Attributes Inspector. I'll go where it says Alignment here. Right where it says Alignment. Right now it's left aligned. I want it to be center aligned. So I'll click on the second button where it says Center. And now it's center aligned. Cool. For now, I want to drag all my controls a bit further down. Right now, it's too close to the notch. So I'll simply point down, click, select all my 4 UI elements, select all my 4 UI elements, and drag them down a bit further down here. About here is about okay. Good, great. Basically, use your mouse, click down on your mouse, and drag over all the elements you want to select, and then you can move them around. Cool? Great. All right, so we have our 4 UI elements. We have our label. We have the text field that the user is going to enter the guess. We have a submit guess. We need to wire that up with an action, and we have the result of the guess. So what we'll need to drag over to our UI view controller, or what we need to connect, we need to connect an outlet to our text field, outlet for our text field, an action for our submit guess, and an outlet for the result. So far, so good? Okay, so let's open up our assistant editor. So go right to the assistant editor where it says editor options, where my mouse is here. Where my mouse is, click on that. Right where my mouse is, click on it, and click on assistant editor. For now, we do not need the inspector window, so you could close your inspector window. You could also close your navigation window, so we have more space, right? I could also close my document outline, and I could close that window, make it smaller. Great, so now I see more code, because we get into wiring up our outlets. Again, as we said before, in your class, in your view controller class, have properties and outlets here at the top. The document outline. So if you see where my scene is, do you see where view as iPhone is? So to the left of view as iPhone, that small box here is the document outline. It opens and closes it. Cool? Great. So we have our properties and outlets here. I could use a pragma mark to describe that. Then I have my lifecycle methods. We'll talk about lifecycle methods on Friday. ViewDidLoad is one of the lifecycle methods of a view controller. Below our lifecycle methods, we could put here our actions and methods, right? Actions meaning like IB actions, and methods meaning our own custom methods, right? Great. So now let's go ahead and drag our outlet. First of all, yeah, our outlet for our text field. So for our text field, select your text field. Select your text field. Control drag from your text field over to where it says properties and outlets here. And for my outlet, for the name of it, I'll simply call it input text field. It's of type UITextField, and it has a weak reference. Again, that's to break the strong cycle, retain cycle from the view controller, right? And at that point, we click connect. So it's an outlet. We dragged it over to our view controller. We called it input text field. It's of type UITextField. And the reference is a weak reference. And we click on connect. All right. So here we have our IB outlet, weak var, input text field of type UITextField. It's implicitly unwrapped here with the exclamation mark. All right, while we're here, let's drag in our second outlet. So we'll drag in our result outlet here. So control drag where it says result of guess, control drag from that last label right below our input text field. And let's call it message label. So it's called message label. It's an outlet. Weak again, connect. And again, if you want to change the name of a property, an outlet, do not manually change it like this, right? We know that's bad. So far, so good, right? What we do is if you want to change the name of a label or outlet, you option click on it, refactor, rename. That's the way we change names. Questions? Right? Okay, great. So here we have our text field, we have our label. And again, it's at the top of your viewDid load. I'm not going to put an outlet below viewDid load here, right? And definitely, well, first of all, Xcode is not going to allow you to put it inside of a function, but put all your outlets up top, and then you could have your regular properties below it, as we'll see later. Now I need to go ahead and drag an action. So I need an action from my submit guess. I will control drag on my submit guess button. I'll drag it over right below where I have actions and methods. It's an action. Object is the view controller. The name of it, I'll call it submit guess button pressed. The type is a UI button, so I'll change that to UI button. It's touch up inside, meaning when the user clicks down on the button, it responds and it calls our method. And I'll click on connect. Great. So we've wired up our two outlets, we've wired up our action. Great. Great, great, great. At this point, I will close, get some more space going here. Get back my navigator, go back to my view controller. Okay, cool. Great. Let's create a new file. We'll call the new file guessing game model. So Command N brings up the new file window. We select Swift file. We go to next. And we have the name be guessing game model. Let me zoom in here so you can see. So it's called guessing game model. It's a Swift file. Make sure that this is checked. Some submissions for assessments, you guys added files and this was not checked. So when this is not checked, your code might work on your machine, but on somebody else's machine, it will give build errors, meaning it can't find the file. So make sure when you create a new file, whatever you're doing, that you have targets checked, right? So here I'll click on create. Okay, so I have my new file created. That is awesome. So we'll create an enum for the outcomes, right? When the user of our application, let me actually run this. Let's go ahead and run our app and see what's the current state of it, because we should have a label and a button show up. Okay, so at the top we have our label. We have a text field, so the user could enter in the guess of 18 to 21 in our case here. They'll click on the submit guess button, and here we'll have a result, right? So we'll create an enum for one of the two cases, right? Case correct, case incorrect. So we'll create an enum for that. Yes? You change. I'm not sure if we're using UIKit here, actually. I don't think we're using UIKit in that class. That's fine. All right, cool. So we have an enum here. I'll call it, what should I call it? Guess outcome for now. And I have a case called incorrect. And I have a case called correct. If you want to go ahead, you could use the lesson as a guide, right? All what I'm doing right now is in the lesson for today. It's right below number 4. Number 4, where it says reading data from a text field, right? So if you're comfortable, you could go ahead, and other people just follow along with what I'm doing. All right, so here we have an enum. I'll call it guess outcome for now. We'll define a class. We'll call it guessing model, guessing game model. So I have a class here. I call it guessing game model. Aha, we're talking about access modifiers today. I will type in private. We started talking about private and encapsulation a few weeks ago. So here I'll create a constant called winning game or winning number. And winning num is an int. Again, marking this private here, I can't access it in a view controller. I can access it anywhere outside of that class, right? When we spoke about encapsulation a few weeks ago, marking something private here is using an access control. So private is an access control modifier, right? Others are public, internal, file private, open. For purposes of us now, private and public. If you don't mark it private, it's public by default, right, everybody? If it's public, anybody could access it. If it's private, nobody could access it except inside of the guessing game model, right? In our case here, we're marking it private because we do not want anybody to change our winning number. In the view controller, if the view controller has access to the guessing game model instance, without saying private here, they could simply say winning number is whatever they want it to be. Okay? We'll see what that looks like for now. Okay, cool. So here we'll have an initializer, and we'll say self dot, I don't have to use self, winning number, what is winning number? Winning number, what do I want to send winning number for? Initialize winning number to a random int. Okay, so here we'll initialize, yes, go ahead.
Sorry, so for private, let's say I put my code up on GitHub, and then you guys were like checking it out. Would you not be able to, you guys wouldn't be able to?
I'll be able to run it. I would be able to run it, yeah.
Would you be able to edit it?
When you say edit, what do you mean?
Well, I guess I'm trying to figure out what private actually does. Like,
We'll see an example, like we'll test it in the view controller and see what it does, like what the private really means. For now, we need an integer. What did we tell the user? We told them 18 to 30 to 21, right? So let's get that, a random number here. So random, let's get a number from 18 to 21, right? All right, let's test what the private is here. Everybody wrote that class. Everybody wrote out the class here? Yes? Okay, let's go ahead and test. Did I hear no? Okay, let's go to the view controller. I'll go to my view controller here. Below my outlets, I will create, do I want to change this? Not really. I'll create an instance of the guessing game model. Guessing game model here doesn't take in any arguments. Build, as you type build, right? So build right when you finish declaring this instance here. So now we have an instance to guessing game model. It's on line 18. In my view did load, I will type in guessing game model instance dot winning. So Matt and everybody else, here I'm trying to access winning number. Everybody, I do not have access to it. It doesn't even come up in autocomplete because it's absolutely private. To our view controller, it doesn't exist. By marking it private in the class, it doesn't exist. If you go ahead and remove the private keyword or change private to public. Let's do it together. So go to your game model and here change private to public, for example. Build it. So now I change private to public. I'm gonna go back to the view controller. I change private to public. I'll go back to the view controller and I'll try to type in winning again. Let's see what happens. So here I'm doing winning. Does winning come up for you? It comes up for you, right? So here, if we have it public, anybody who has access to my property could change it at any time. Everybody, they could change that winning number at any time without me being aware or me approving it. At this point, I have no say. Because I marked it public, I said anybody could enter my house. There's no key there. There's no lock. It's public by default. So if you remove the public keyword, it will still work. Right? Hey, it's not going to change because we said this is a let here. Well, it's still going to, sorry. So if we change to, go back to what David is saying here. If we go back to our guessing game model, take out public. By default, access control, yeah, it's public. Access control on all properties are public. Right? Make this a var in order for your code to run, because right now you're trying to change a constant. Okay, so by default, it's public, everybody? And again, as I said, with some code submissions, you have to be really explicit with everything. Some people are really anal with everything when it comes to code. So some people actually want you to go ahead and say public, even if by default it's public. Okay, everybody? Right? Cool. All right, so let's go back to private. Do we all know why we marked it private now? Right? We don't want anybody outside of our guessing game model to change our winning number. We're the ones in charge of changing our winning number. We change our winning number here. It's up to us. Everybody? I'll show us something briefly, right? A next way you could make something public, I could make it public in my view controller, but private to set. What's that? Because those are one of the things I should probably just hold off on. I'll hold off on that one. I could have made the view controller have access to it, to read it, but not write to it. Right? We'll come back to that later for purposes of, we'll come back to that later. All right, great. So we have this private, we changed it here. So at this point, we initialized it. It has a winning number. We go back to our view controller. Are we done with our game model? We defined a method that takes, no, we haven't. So go ahead and do the last step. Everybody has access to the lesson. In the step 3 model, do the last step. Define a method that takes a guess as input and returns something of the type of enum that you defined. Our enum that we defined, we call it guess outcome. I'm still not happy about that name. Anybody has the next name? Was it? Guess result or game result?
Yeah.
Game result? Yeah, that's better. That reads better. Okay, so we know what we're writing. We're writing a function. And again, properties, initializers, methods, right? So here, you want to do properties first. Get used to doing that. That's the way you format your stuff. Properties, initializers, and down here you have methods. Yes, sir.
Sorry, why can't we just set like int.number in the variable?
You can, but here we're using an initializer, so every time you create a new game instance, you'll get a new number. Cool? Great, so now we are writing, we all have access to the lesson, correct? We all have access to the lesson here. I'm talking about our model, that last step here. Define a method that takes a guess as input, and the guess should be an int, right? Our guess should be an integer. Everybody? So it takes a guess as input and returns something of the type of the enum that you defined. Clarification? Yes?
Is the guessing game model dollar number within the
We could. I think we were just testing this, right? So take that out. Go back to VD load. That was just for testing the private access control. Brandon, right? So our VD load, everybody, VD load is empty for now, right? Minus the super.vd load. Okay. So we're going back to our guessing game model, and we're implementing the method. You're welcome. I changed it to game result. You could actually go ahead and do the logic too for the function, right? The function needs to return an enum instance of whatever that enum we called. So basically you do the logic, figure out if the guessed number is the same as the winning number. Does that make sense? Right? So here we have a winning number, right? Internally we have a winning number. Our function takes a guess as an input. Yes? So we just have to compare that guess we got from the function to the winning number. If they're equal, then you return correct, right? Right? Everybody? Okay. And correct is obviously an instance of game result, which satisfies the method signature. Our function parameter needs a label name. Great, great, great. I went around and I saw good things. Good, good, good. Good job. Are we back? Are we back? We excited? We're back. We all got it. Okay, so we created a method here. What did you call your method? What's that? Get guess? All right. Guess answer. All those are good. What does it take in? A what? Oh, one at a time. Sorry. A mini. Go first. Yes. So here we have game status, and then what's the next thing? So we're taking in some guess number. It's an int, right? Everybody had an int for the data type. And it returns, what data type does it return? Guess result, very good. Well, mine is probably called game result. Awesome. So here we return in incorrect or correct, correct? So here we have guess number equal to winning number. Return correct here, or return incorrect. What? Wait. What happened? Am I doing something wrong? You remember ternary operator, right? Remember ternary operator? That's ternary operator. Eric said that 6 weeks ago, so that's old news. That's what Eric said. All right, awesome. So we have our game status. Is it private or public? It's public. If it's not marked private, it's public by default. Same as properties. If it's not marked private, it's public by default. Everybody? Right? Excellent. So let's go back to our view controller. Let's go back to our view controller here. Are we all done with our guessing model? Yes? No? Okay, so we'll take a few seconds here. If we're not done with something and I'm moving on, please just raise your hands and say, wait a few minutes or something. I don't want to, I try my best to pace down a little bit so we all could catch up. Yes? I renamed it to game result. You could keep your name if it feels better for you. That's fine. Luba, how are we doing? Good? Everybody else, we typed out? Cool. All right. Let's go to our view controller. Our action doesn't do nothing right now. So when we click, user enters something. When we click on our button, we want to find out if it's correct or not. I think we have enough of fundamentals to do that there. So I'll let us do that. So write some logic to figure out if the user won or not. So what you're doing is, do we have instructions for this? Complete the method inside change the message. All right, basically what this says, but a bit more stuff there. So complete the method inside your IB action to change the message. When I say the message label. Everybody? We have a message label, correct? This message label here, right? We all dragged in a message label. The message label is on our app. That message label is this one. It says result of guess. Result of guess. Do we see that? So when the user enters some guess, we click on submit guess button. It calls our action. Our action, we need to do some logic in there. And that logic we do, based on incorrect or correct, we change the label down here so we know if we guess correctly or not. Does that make sense to everybody? Right? So again, we have enough of fundamental knowledge there with Swift to be able to attempt that challenge. So I'll let us do it and we'll come back together to do it. So in our submit guess button press, you need to, let's see, to do. We have an instance of guessing game model. Everybody has an instance of guessing game model, right? So here we have an instance. That means we have a number. We have a winning number already. The minute we said guessing game, open parens, close parens, what got called? In our guessing game, what got called? When I said open parens, close parens. But what got called? What got called? What explicitly got called in my guessing game model? Huh? In the class, which one of those things got called? What gets called first when I say open parens, close parens? Initializer, right? I heard it. Initializer. So when I say guessing game model, if I go back to my guessing game model Swift, this gets called. This gets called and it creates the random number. Let's all put a breakpoint here. Let's all put a breakpoint inside of our initializer. Put a breakpoint. So click on whatever line number your winning number is on. Click on it. Make sure it turns blue. That arrow there in the gutter. Everybody, go ahead and run your application. Command R. Command R, run your application. At this point, our application stopped, correct? It stopped because we just called our guessing game model. We just initialized it. In your view controller, if you go back to your view controller, on that line, on line 18, guessing game model, open parens, close parens says, create me a new guessing game model. That's an instance. When I say create an instance, that's what happens in that instance. It goes ahead, it calls it class, it uses the initializer. In our case, our initializer doesn't take in any arguments. Yeah. Yes, right below our outlet here. Instance of guessing. Wait, it's not on the storyboard. The model is just a Swift class we created.
No, granted, but when I make instance of guessing game model, I made my instance on the storyboard, so it still popped up on, so it still showed up on my view controller.
When you say you made an instance on your storyboard, walk me through that.
Well, so on my storyboard, I put let,
On your storyboard, this is a storyboard, right?
no, the main storyboard, which is the attribute. I mean, the assistant.
The view controller. The view controller.
It's the same thing.
Yeah, storyboard is where you see the view, the scene, the iPhone.
When I put assistant, it goes to,
It opens up that window, yes.
because I wasn't pressed on the control, I was pressed on.
It opens up that window with the view controller code in there. Yeah.
Assistant is what crosses the goal to show.
Exactly. That way we could control drag our out.
So it wasn't the right place.
All right, very good. Okay, so going back again, our view controller, we have an instance. When you create an instance creates a new object. Everybody? So an instance creates a new object. This here, that code here on the right side of the equal sign, it creates me a new guessing game model. The way we get a new model is using an initializer. Everybody. So that initializer that we have in the guessing game model here, that initializer, it gets called because I'm about to create a new instance. Right, everybody? So in that initializer, I go ahead, I say int random, get me a random number, and random number gets assigned to winning number. At this point, we could say PO here. In the console, bottom right, type in PO, winning number. PO, print out, winning number. Put a next breakpoint on 27. Put a next breakpoint on line 27, right? And see where I am now. You see the play button at the bottom here? Like continue running program. Do we see that play button here? Do we see that play button? Click on it. It's going to go to the next breakpoint. Click on it. It goes to the next breakpoint. Did we get to the next breakpoint? Right? And at that point, let's go back. Let me zoom back here. I could simply go back to my console and press on the up arrow. Press on the up arrow. It should give you back the last command you did. Yes? Press enter again. And look at that. I got 20. You probably got different numbers, obviously. Right? At this point, I was able to use breakpoints to investigate what happens with my code, right? At line 26, it wasn't ready, so you saw some random number, right? Made no sense to us. So we use a different breakpoint because the winning number wasn't set yet. Winning number wasn't set yet on 26, but winning number is set on 27. Okay? Okay? Questions? So, know your initializers, know how your objects get created. Your objects get created via an initializer. It has to be some initializer of some sort, whether it takes in arguments or it doesn't take in arguments. But some initializer needs to be called on a struct, on a class, whatever it is. Okay? Great. What is not working? Put a breakpoint on 27. One thing you could do too, Luba, stop your program from running. Luba, stop your program from running. Okay, let's keep going. So we know what the initializer happens, what the initializer does. We know it changes our winning numbers to some random number between 18 and 21. That's great. Now we go back to the view controller, and you guys, for the to-do here, we have an instance of guessing game model. So call the function that you wrote. My function is called game status, right? So if you go back to your model, whatever function you wrote, whatever the name is, my name is game status. Whatever name that you guys created, call that. So call, in my case, call game status. Set message label with appropriate message based on the user's guess incorrect or correct. Right, so what you're changing is the message label. Right, so change the message label. Two things you're doing. One thing you're doing, you're calling the function, and you call game status using the guessing game model instance. Guessing game model instance. Right, so you call that instance, it returns some value, and on that value, you'll know whether it's incorrect or correct. And on that, you'll say message.label.text equal to whatever it is. Do we know what we're doing? Is there enough information here? Is there enough information here for us to do that logic there? Yes? Good? All right, cool. So Brendan says all is good. If there's any questions, ask Brendan. Yes?
No, I have a question because technically the hints that they're supposed to get.
Oh, there's work you need to do, right? We know how to do that.
No, I don't.
Oh, so there's one more step. That's what you're saying. I think you're saying there's one more step.
You have to get the
There's one more step, right? Okay.
So you have to use the UITextField. It's going to be the UITextField.
Ah, Brendan, you saw that one? Ah, Brendan said he do now. Okay, so one more to-do item here. Thank you, madam. So to do call game status, that's one thing. We need to get the user's input. We haven't gotten the user's input here. So set message label. Here, get user's input. So user get string from TextField, from UITextField. How do we get a string from a UITextField? Those are all the questions. Get string from UITextField. That's one thing. Convert string to int. Then we could call this guy. right? That's clearer. So one, get string from the UITextField. On a UITextField, you could simply say, example, what's the thing called? Input text field dot text. That gets you the string the user entered. Everybody? Everybody. My text field is called input text field, correct? If I want to get the string that the user entered, I say input text field dot text. That gets me that string. And that string I get, I convert that string to an integer, and then I call my game status. My game status takes in an integer. So I call game status, I pass it the integer. What does game status return? Oh, what does the function that you wrote return? Some sort of enum, a game result enum, right? So based on that return, I'm able to set my message label. A few steps, but I think we have enough information now. Sir, we are good. So Brendan says he's still good. Questions? We need to start writing logic, right? Because we coders at the end of the day. So those little challenges there reinforces our learning. And we're doing it together as a class at the end of the day. So that's a good one there, right? So the user clicks on submit. At the end, we just update the label, the message label. But there's work we need to do before that. That's the steps here. Step 1, step 2, step 3, step 4. And how do we set message label? Do we just say message label equal to string? How do we set the message label? Very good. So Tanya says message label.text, right? Great. Awesome. So those are the steps. If you want to take a short break, come back and do it. That's fine. But just don't take more than 5 minutes. Step 4. Oh, okay. That's fine. So let's. We may have to get to the thing actually. How do I? All right, good, good, good. Mid the rounds, you guys are doing good. Feel free to, because I think most people got it by now. Feel free to reach over to your partner and see where you got stuck and get unstuck there. Because I think most of you guys got it based on what I saw. All right, great. Let's do it together. Step one, what are we doing? We need to get the text from the text field, right? So we have a text field, a UI text field. It has a property called .text, and that .text gets you the string that the user entered. So far, so good? So that's number one here. Should we just do it in line? Do it in line, it's fine. Great. So here, step one, let's get this string. So user input. User input is the input text field .text. Right? I'll do it multiple steps. I know some people did everything in line, which is fine. Here I'll say guess number. Guess number should be some sort of number. We know we could take a string and convert it to an integer, right? Using integer initializer here, I could pass in my string, which is user input. User input is optional because text here is optional. So I'll unwrap using nil coalescing here, right? So my user input is no longer optional here. Great. So if we option click on user input is a string. User input is a string, which is great. And my guess number, I'm saying go ahead and use my integer initializer, pass in a string, and use nil coalescing to give it a default value of 0. So guess number is no longer optional. So here I use nil coalescing for both my text field.text and for my integer conversion. So at this point I have a guess number. So I did number 2. All right, number 1, get the string, we did that. Number 2, convert string to int, we did that. Number 3, call game status using the guessing game model instance. So here we have to call game status. How do we get access to game status? Game status is an instance method, right? We call instance method using the instance. So here the instance we have is called guessing game model dot game status. Game status takes in some guess number. The guess number will pass in guess number from above. At this point, if we get in a compiler warning here, it says result of call to game status is unused. What does that mean? I call the function returns a value, I haven't used that value. I need to use the value. The value, what's the value here? What's the value returning from our game status function? Yes, Tiffany? Right, so it's the enum of correct or incorrect, right? Our enum, if we go back to our game model, our method returns an enum game result with 2 cases. Either it's correct or it's incorrect, right? So we have to make use of that result, that return result there. So I'll create some constant. I'll say result equal to. Great, so that's number 3. We use the game status, we call the game status function, we got result. On to number 4. We need to set the message label, right? I need to set the message label. So here we have message label dot text, right? Gets assigned some value, right? The value here is result. If result equal to correct, right? If result equals to correct, then I'll say my message label gets whatever. Correct guess is good. Correct guess. Or it will be incorrect guess. That's a ternary operator, right? That's what we did earlier. Very similar to if else. Yes, Luba. Very similar to if else. We saw that earlier. I want us to start seeing it again because it's one of those things, if you haven't done it for a while, it's very easy to forget it, the syntax of it, right? So in a statement like that, we have one statement, not much happening as far as the complexity. A ternary operator is good, right? And also SwiftUI, like looking to the future, ternary operators are used a lot in SwiftUI. So it's one of the things, like the more you use to it now, the better. All right, great. So now we have our message label has been updated based on number 4. Let's go ahead and test our code. I'll run the app. I'll run the app. I will make a guess here. Let's see, 19. Submit guess. Incorrect guess. Okay, let's try again. 21. Submit. Incorrect guess. 18. Submit. Correct guess. Okay, so I got there on the 3rd try. But that works, right? Everybody else's work, right? You guys solved it yourselves. I saw that as well. Very, very good job. Great. So that works for that button. But the purpose of today was to talk about UITextField delegate as well. So now we need to refactor our code. We love refactoring code, right? We need to refactor our code so that when I press this button here that says return, do we all see the return on our keyboard? When I press that return button, I want it to do the same logic as the submit guess button. Everybody? Right? So we need to conform to UITextField delegate in order to get the delegate methods, right? UITextField delegate is a protocol. That protocol has a list of methods. All the methods are optional, right? But one of the methods gives us access to this return button. So when I press return button, it's going to be the same logic as the submit guess button. So far, so good? Because the user of your application expects that return button to work, right? We all expect when we click search or we click done on a keyboard, something happens. Right now, nothing happens with our return button, so we need to make that work. User experience is bad here because the user expects the return button to work. So far, so good. So let's go ahead and do that. Yes, sir?
I have a question for, so if we have set it private, like an incorrect guess, you can't like say incorrect guess on number was.
Oh, you mean you want to get access to that?
Yeah.
Okay, so Kelby has a good question. His question has to do with encapsulation. If we go back to our model here, Kelby is asking, I want to get access to winning number. Right now, we cannot get access to winning number. Do we all see that? Because winning number is private. According to encapsulation rules, we've done our job, right? We made our properties private. That's pure encapsulation there. But if you want to have access, you want outside people to have access to your winning number, you could simply have a function that returns winning number. Right, so here I could just simply write a function. You could call it get winning number. Get winning number, it doesn't take in any parameters. What should it return? What should it return? Winning number. So here, return winning number. And what's my return type? It's an int. So now we have access to get winning number in our view controller. Everybody with me here? Right? So here we have encapsulation 100% intact here because our property is private. The only way Kelby could access that winning number now is via a method. So in his view controller, he could say game model dot get winning number. Everybody with me? Right now, there's still no way Kelby could change winning number. The only access he has is to retrieve a number, not to set. Cool? That works for you, sir? Very good. All right, great. Yes?
Is there a way to create like those type of methods automatically? Because what happens if you have too many properties to create?
If you have 10 properties, whatever number of properties you want, there won't be an instance where you want to have every property being returned on that value. that object hasn't been architectured correctly, right? For you to be returning every instance of that object to somebody, right? In our game here, the big thing we're after is a winning number, right? You could use a tuple if you want to return multiple numbers, right? You could use a tuple for that. Like we could simply use a tuple for game status. We could refactor this and return a tuple, right? I could return a tuple here, make this guy a tuple, and return a winning number along with the incorrect or correct, right? You with me, sir?
Yeah.
All right, cool. Good. So let's keep going here. All right, so we need to refactor. We love refactoring. One good way to refactor, everything in that particular submit guest button is not tied to the submit guest button press. Do we agree? None of our logic here is tied to the sender, right? There's no sender dot button title or anything like that, correct? So that whole function, as a matter of fact, let's see how we could do this. So go ahead and copy, not copy, but highlight the entire body. Highlight the entire body of your entire logic. Highlight the entire logic. And you could right click on what you highlighted. Do you see refactor? Do we all see refactor? Do we all see refactor? Okay, let me go back to the previous step. I'm in my submit guest button pressed, right? We wrote all the logic for changing the message label. So now I want to remove that code and put it into its own method. What I'll do, I will highlight all the logic here, highlight all the logic, right click on it, go to where it says refactor. Do we see refactor? Do we see extract method? Click on extract to method. It extracted everything to its own method, and now we could rename it. It still gives us an option to rename it. What should I name this? I'll call it check guess or something. Check guess. Check users guess. Go back and redo it. Sure. All right, we here. Are you here? You highlighted all your code inside of the open and close curly bracket. You highlighted, you're not able to right click, like mouse right click. The extract is grayed out.
You have to not include the very last curly black.
Yeah, we don't have any curly bracket.
At the bottom, yeah.
All right, we'll come around and help you guys with that. For now, let's just keep it simple. Keep it simple. Command X, right? Cut the thing, and let's write a function. Function check users guess. Command X, I cut the entire body. Yeah, Command X. If your refactor is not working right now, that might be an Xcode bug where you have to close Xcode and reopen it. So Command X meaning cut that entire block of code and paste it inside our check users guess. Right, everybody? Awesome. Good. So now, questions? We're not going to use the submit button anymore. We're refactoring our code. We'll be removing, deleting the button. We're not using button anymore. We'll be using the text, the keyboard. Cool? Any questions before we move on? Did you Command X? Create a function, func, check users guess, open parens, close parens, open curly, close curly, and paste it inside that body. Melinda? We here, right? If you're able to refactor, you're great. That's the best way to do it. Okay, Mel, are you here? You Command X, correct? Yes? Are you in the submit guess button pressed? copy all the code in there, including the comments. Copy all the code in there, including the comments, correct? And then Command X, right? Go ahead and create a new function. We called it check users guess. That's fine. Some people, theirs was not working. Cool? Mel? And paste it in here. Remove file private, just remove the file private. If yours has file private, just remove file private. Okay? All right, perfect. So we all have our method outside of the submit guess button, correct? Correct. We know we cannot just delete this, right? That's going to be bad news, right? So we want to get back to our view controller and disconnect it. No, sorry, our storyboard. So click on your storyboard. Click on your storyboard. Get back to the assistant editor. Click on your storyboard, get back to the assistant editor. You like to see it there? No. The TextField is going to take care of that, as we said earlier. The keyboard, when the user clicks on return. All right. So right-click on your Submit Guess button. Right-click on your Submit Guess button. Do we see where it says touch up inside with the X? Do we all see that? I'm going to slow down the pace a little bit more. Do we all see the X here? Click on it. At this point, we're not connected to the button anymore. Everybody? Right? No, it's still going to be connected to the action. It will crash the app. Yeah, you can. You can. Okay, so at this point, we disconnected from the action. Everybody, make sure you disconnected from the action before you go ahead and delete this block of code. When you confirm that you did disconnect the button to the action, delete the IB action. Okay? Okay. Close out your assistant editor, go back to your view controller, right? To review, we've just refactored our code. We removed the button. Did we delete the button as well? Go ahead and delete it. Just delete it. But confirm that before you delete it, did you disconnect it? All right, so go ahead and delete. Delete, go back to the view controller. And let's start talking about delegates and protocols on UITextField. All right, awesome. How are we doing? We good? Can we continue? You guys want a break? Everybody good? Thumbs up? All right, we'll continue on. All right, great. Let's go. Good. All right, so we have our text field. We want to be able to go ahead, get to your app. When I click on that return button, I want my guess button, my guess function to still work. When I click on that return button here on my keyboard, I want my check users guess to get called. Everybody, right? So let's see how to do that. We'll do that via conforming to UITextField delegate. So how do we conform to UITextField delegate? One way we could conform to UITextField delegate is to put a comma after the UI view controller. So UI view controller here, that's the parent class of the view controller, correct? So this reads view controller inherits from UI view controller, correct? Can I inherit from multiple classes? You should have seen your conviction. For the job, can I multiple inherit? Yes! I got you. All right, so there's no multiple inheritance in Swift, right? But we could conform to protocols as many times as we want. In that case, we want to conform to UITextField delegate. So here I could put a comma here and put UITextField delegate, like that. At that point, build your application, make sure you have no errors. So here we're saying we're conforming to UITextField delegate. On our UI view controller, we have a comma, and we have a protocol which is called UITextField delegate. UITextField delegate has a set of functions you could use to get notified for based on what the user does with the text field, right? At this point, nobody would have an error, right? Like, hey, you're not conforming to it, correct? We've seen that with case iterable. We've seen that with the protocols we wrote ourselves. But remember I said yesterday, all the methods on the protocol for UITextField delegate, all the protocols are optional. What does that mean? I don't have to implement any of them. Because right now, my code works. There's no compiler error. It's up to me to say which one I want to conform to or implement. Everybody with me? If we go back to the documentation, not go back, or go to, so UITextField delegate here. UITextField delegate. Can we all see in the back? Can we all see in the back? Okay, so UITextField delegate, it is a protocol, as we said. It's not a class, it's not a struct, it's not an enum, it's a protocol. We've created protocols from yesterday, right? So here it says, a set of optional methods. All the methods are optional, okay? If we scroll down, let me slug that out. If we scroll down, let me slack it out. All right, so if we scroll down, right where it says topics, Apple does a good job as far as like headlining what the things are. So here it says managing editing. Managing editing. There's a method that tells you should begin editing, should that text field take an input. There's a method for that. On the protocol, all those methods we're seeing there, they're written on the protocol. We could make use of them if we want to. Text field did begin editing. There's a method that tells us when the user starts editing the text field. Should end editing. Should I do something as the user ends editing, right? There's methods for all that. Editing the text field's text. Should change characters in range, right? There's a method for that. As the user is typing, should they be allowed to type more than 10 characters? You could stop the user using that function there. Should change characters in range. Should return. This is one of the functions we're after today, right? In that method, it gets called when the user presses the return button. That method gets called, right? So let's go ahead. In the lesson, it specifies all the methods that we'll be testing out today. If we go down to, what number is this? Go down to number 5 in our lesson. Number 5, go down to where it says text field begin editing here. So before we start typing those methods in, I want to do one more thing. I want to show us one more thing. I said we were going to see extensions today, and we will see extensions today. Because one of the Swifty things to do when you're extending a class or you're extending to use a protocol, one of the Swifty things to do, one of the coding conventions to do is have an extension on your view controller. Have an extension on your view controller. It basically says this extension is a continuation of my view controller. So I'm going to take away everything that has to do with the UITextField delegate inside of an extension, okay? That makes my code easier to read, easier to debug, okay? So here I will remove UITextField delegate here, if we're all following along. As I do it, we'll go over it. So I remove the UITextField delegate. Everybody with me? We'll go all the way down, past the last curly bracket. Please, past the last curly bracket. Put some spaces in there, some return new lines in there. We'll create an extension on our view controller. In that extension, we will conform to the UITextField delegate. That decouples, it takes that code away, a mini, from the view controller itself. Our view controller stays smaller, and we take all the extension, all the protocols for the UITextField delegate into its own block of code using an extension. Right? That's one of the use cases for an extension. First time we've seen extensions today. But extensions, you could extend functionality on any view or any class. I could have a class called, well, I could have my UI view, I could extend UI view and have its own functionality. We'll see more of extensions as we go through the program. Remember, when we get introduced to something in iOS here, we see more of it as we go. Today is just the initial process of it. First day, we see extensions. We're using it to extend our view controller to encapsulate the UITextField delegate into its own block of code. Okay? So here we use the keyword extension. It extends the UI, it extends our view controller, right? Same name as our view controller above. Right? Same name. But here, I want to conform to my UITextField delegate. That breaks up my code. It's easier to debug my code. I know everything inside of that block has to do with UITextField delegate methods. Everybody? Okay, cool. You could even put a pragma mark here if you want. And here I could simply say UITextField delegate methods. I saw a hand up. Yes, sir.
So yesterday we were doing a lot of conforming to protocols and like kind of sticking them all on the same line. Should we from now on?
Yeah, break them up. Yeah, definitely. We'll see that a lot starting next week when we start doing table views. Yeah, but break them up using extensions for sure. Some people even go further, and some people actually have it in its own file. Like they take that block of code here, put it in its own file. But for purposes of what we're doing today, we do not need that. Great. So here we have our UITextField delegate. We conform into it. Since we conform into it, as we start typing TextField, all the methods available to us on the protocol TextField delegate starts showing up, right? So let me do that again. As I'm typing in TextField here, Xcode gives us all the options available to us as far as the functions for the UITextField delegate. Everybody with me? Right? So the first one we want to implement is should begin editing, or you could even actually just type in should begin editing like that. It should come up. Should begin editing. Press enter. Here, just return true. Firstly, we'll type in all the functions. We'll run our code, and we'll see how, when we type into the text field, how the functions get called. Right? That's our objective for now. So go ahead and copy the name of the function into a print statement. Copy the name of the function and simply put in print text field should begin editing. We could actually run it now and see if this function actually gets called. So run your project. Run your project. Aha. It's not getting called. It should get called. Yesterday we brought up something that said, if you don't do that step, your methods won't get called ever. And we'll get into those situations many times. Like we conform into UITextField delegate, We have the methods. It should be calling the text field, should begin editing, but nothing happens. So yesterday we did one of those steps in lab and also in our lesson. Anybody has any clues as to what we're missing here? Somebody wants to listen to changes on the text field. That somebody is the view controller, right? Our view controller, the view controller. How do we set ourselves to say we the delegate? How do we set ourselves to say we the delegate, we the one listening to changes on the text field? How can we do that? The what? Some sort of variable, some sort of property you need to set. Yes, sir. Yes. So yesterday, as we saw, yes, you said it, right?
I did.
You were not sure. So yesterday we saw it. We said, what did we have yesterday? We had a blackjack game, and we said blackjack game that delegate equal to view controller. We need to do that here today. You also did it in your lab. If you had your lab complete, number 6, you had to set the receiver, the delegate on the receiver as the view controller. Without doing that, you're not saying to the view controller, I am the delegate. You need to explicitly say that. So let's go ahead and do that in the viewDid load. So let's go to viewDid load here. And we have access to our input text field. Our input text field has a property called delegate. On that delegate, yesterday we said view controller. Today we'll say self. Why will we say self? Because self is the view controller. Everybody with me? Remember, self is the instance of that view controller. So today we say input text field that delegate is self. Yesterday and in lab we said view controller. Today we say self because we're in the view controller that we reference it. Okay? So here we simply say self. So yesterday we did 3 steps. 1, we created a protocol. 2, we created a delegate variable. 3, we set that delegate variable by this step here. So we need to do that. You could have everything functioning as far as like you have your functions, you conforming to the UITextField delegate, and you forgot that step, your methods are not going to get called. Okay? So you need to say input text field, where the user is entering their input. Delegate is the view controller. Now the view controller, the methods will get called on the view controller because the view controller needs to explicitly say, I am the delegate for the text field. I am listening for changes on that text field from the user, okay? So we'll end up forgetting that a lot, but we'll get used to knowing what is happening. And a good place to set it is in the viewDid load. Because in viewDid load, that's the first function getting called as the view comes on screen. So that's a good place to set the delegate on your text field. Okay? Let's go ahead and run the app again. If everything was correct and we set our delegate, as you click into your text field, you should see text field should begin editing on the console. Cassandra, have you set your delegate in the viewDid load? Mel, did your print statement come up? Okay, let's go back. So make sure that in the viewDid load, you say input text field that delegate equals self. Did we do that? On your extension, Mel, let me take that a little bit in here. On your extension, did you implement the text field should begin editing? Do you have a print statement? Cassandra, did you get your console log? Let's go back. Are you conforming to UITextField delegate? View controller, right? The name of your class is the view controller here? And you're saying TextField should begin editing, right? And you have your TextField up here. And in your viewed load, you have input TextField.delegate equals self, right? Anybody else not getting their console to print? You? Matt, did you get yours? Okay. Greg? Good? Yulia? Okay, so we have two fellows missing the print statements. We'll pass around and we'll see what's happening. You should delegate there. All right, cool. So, yes?
Sorry, I just have I want a little more clarification on the connection between self and like the delegating.
Oh, okay. So the delegating is you registering yourself as listening for notifications.
You're registering.
The view controller itself.
So does that delegate isn't registering a delegate? It's like turning it on so it would,
You the delegate, like self,
the whole instance.
the whole view, yeah, exactly.
And it's checking what those changes.
It's checking for those changes because so far we've only implemented one method. We'll implement other methods. But anytime there's a change, since I'm the delegate, I get those updates.
So the whole view controller.
The whole view controller instance. Yes, exactly. View controller. Any other questions? Good questions. So self, as Julia says, represents the view controller instance, right? Okay, cool. So next up, we have TextField did begin editing. Let's go ahead and implement that. So start typing in did begin editing, press enter. So the first function returns a Boolean value, right? True or false, right? Should begin. If you return false, obviously the user cannot enter anything. So here we return true. The second method says TextField did begin editing. It lets us know that the users did start typing in, right? So here, copy the name of the function and simply print it out. Again, the purposes of this demonstration is just for us to see what's happening as we're using the text field, right? What functions are getting called, what print statements are happening. That way we understand how the input text field delegate works. So text field did begin editing, that's great. Let's go ahead and type out all the functions here. Start typing in should change characters, and press enter. Return true for this one. And copy should change characters in here and just print it out. Simply print it out. All right, we'll pause here for now. So far, this is the third function we implemented. The second one was the user did start typing. That function gets called. Our delegate gets called here. The third one says should change characters in range. Remember we saw that on the API documentation. This function is very powerful. This function, if you want to limit the amount of characters your user enters, this is the function to use. As the user is typing in characters into the keyboard, this function gets called every time. Every time the user enters a character into the text field, that function gets called, okay? So if you want to limit or check for characters or validate anything, this is the function for it, okay? For our guessing game, we will use that function to capture if the user entered a guess before. Right? If they entered 21 before or some value like that, we could check here and validate it. Okay. Did we all type that function in? Should change characters in range. For purposes of time, I will just get to one more function. Remember, if you want to get more information about any API, we could go back to the documentation, okay? So let's go and type in should return. So should return, this is the main function we're after now. So should return, for now we return true. It returns a Boolean value. And we copy should return and we print that out to the console. Cassandra and Mel, were you guys able to get your print statements happening?
Yeah, I just had to go.
That's okay, that's fine. And Cassandra, you got yours working?
No, I'm just trying to.
Okay. All right. Cool. All right, so we'll stop here at the 4 functions. There's many more. But for what we're after now, we'll stop at TextField should return. TextField should return, that's the one that gets called when you click on that return button on the keyboard. Everybody? So we'll go to that function and update or call our guest, our check guest function there. What's your question, sir? You had a question? Okay. All right. Go ahead and run your simulator. Command R. Run your simulator. Bless you. Okay, let's see what happens. So we go to our text field. We click in our text field. Did begin editing, got called. Everybody? Everybody. A lot of conversations happening outside. So did begin editing, got called. I'm typing in 4. Do we see the console? What's happening in the console? Clear your console. Do you remember how to clear the console? We clear the console by clicking on that delete button. Let me zoom into the delete button. Zoom into the delete button. Do we see the trash bucket at the bottom? Click on it. That's going to clear your console. Get back to your simulator. Type in any character. As you type in, the should change characters gets called every time you type a new character. Do we see that? Right? Every time I type in a new character, that gets called. Right? So if you want to check any validation, right, that's where you do it. That is one of the most powerful methods that our protocol has. You want to restrict the amount of characters. You want to check if that user entered that specific character already. This is the place to do it. Right? Let's go over the arguments on that particular method. So the first one is the text field. Text field is the text field, the current text field being edited. Right? The current text field being edited, we could have multiple text fields. Right? We could have multiple text fields in our view, obviously. We all used a login system before. We have a password text field. We have a username text field. Those are 2 text fields, correct? So you could use that same method for multiple text fields. And I could do something simple as if, don't type this in, but I'm just showing you how you could differentiate between text fields. So I could say if text field equal to input text field like that. If you have multiple text fields, you could use that particular logic here. If text field equal to the input text field, do some logic. Right? Yes, sir. You conform, your view controller conforms to the text field delegate, and when you come inside of your should change characters or whichever method, you check which text field is being edited. If text field equal to text, yeah, inside the function. Exactly, yeah, exactly. You want to do it inside that delegate function. All right, so again, this is, actually just type it in and just comment it out so we know if we have multiple text fields, how to approach it. So type it in and comment it out. And then I'll just put a comment here, differentiating between multiple text fields. All right. So again, text field is that text field parameter here. We have a range, like what's the current range that the user is editing? And then we have the string. The string is that exact character the user is added. String here is that character the user is added, right? That string, that last string, that new string the user is about to enter, that's that string property, okay? More about that API. If you want more about that API, you could go to, can I go back to the documentation? Can I go back to documentation? Yes, no? All right, if we go back to documentation here, so this one here, this is a very important one. So should change characters in range. It shows us the definition of the function. Here, TextField is the text field containing the text, the range of characters to be replaced, and the string. This one is a very important one. The replacement string for the specified range. During typing, right, as the user is typing, this parameter normally contains only one character at a time, unless the user is pasting in some text. Everybody? Unless the user is pasting in some text, this is normally one character at a time, right? We do not enter two characters at a time. Luba, question? Okay. Cool. And here you return true if you want the user to keep typing, or false if you want to stop the user from entering any text. Right? The return value here. Yes, sir. Say that again. Yeah, like you could have a count. You would have to have a count and then have some logic. If the count is whatever your max is, then return false. Return false. Yeah. All right. Good. So this is good. Everybody got the delegate to work right now, right? We all have our delegates working. Great. Let us move on to should return. Time is just flying here. So should return. Let's see if that actually works. Let me get to my simulator. So should return. Everybody has a print statement saying TextField should return, right? And we have our should return. Now go ahead and click on the return key. On the keyboard, click on the return key. What happened? It got printed, right? Yes. So Command-Shift-K. Click on the text field, and then Command-Shift-K. Click inside the text field, and Command-Shift-K. Did it show up? So click inside the text field here, and Command-Shift-K. Okay, so as we click on the return function gets called. Do we see that? Right? So this is where we want to have our check game status or whatever function we call it. That's where we want to call it. Everybody? So I want to call it when the user clicks on that return key. Okay? When the user clicks on that return key, I want to say if they won or if they guessed incorrectly. Okay? Remember, we refactored our code. I know it might be a while ago we did that. We refactored our code. We removed the submit button. Now let's actually add the call to check users guess now. Everybody? Cool? So let's go to should return and simply call your check users guess. One other thing we want to do, as we click on the return key, we want to dismiss the keyboard. When the keyboard comes on screen, right? When the keyboard comes on screen, the keyboard becomes the first responder, right? It becomes the first responder in the responder chain. It becomes the first responder. It comes on screen, it's the first responder. In order for us to dismiss the keyboard, we need to say resign, first responder. Everybody? To dismiss the keyboard, in my should return here, to dismiss the keyboard, dismiss keyboard by typing in TextField .resign first responder. We could actually remove the print statement here for now. We don't need that anymore. So here, when I click on my return key, it dismisses the keyboard by using resign first responder. Because as I said, when the keyboard comes on screen, the keyboard is the first responder. To get rid of the first responder, we use resign first responder on the text field. That's what you want to get rid of. Right? So dismiss keyboard, text field dot resign first responder. Let's test our code. So our keyboard comes on screen. The user enters some guess here. We enter 20. We press return, right? We press return. The keyboard goes away. And our function also gets called because now I have incorrect guess here. Everybody? All right, did it work for us all? Right? So that worked. Any questions so far? Let me make that a little better here. So correct guess, let's just put an emoji here of some type. And incorrect guess. Oh, where am I? The text field has a property called resign first responder. Resign first responder, what it does, it gets rid of the keyboard. Text field is the first responder right now. As the keyboard comes up, text field is the first responder. So we want to get rid of the keyboard. We dismiss the keyboard by saying, text field, get rid of that keyboard for me, please. Yes, yes. We do not explicitly need to say input text field here because for now we only have one text field. Cool? Very good. All right, awesome. So we did that. Okay, cool. So let's see. So for now, we have our UI. The user could enter 20. They could press return. That's good. But we want to have the user not be able to enter 20 multiple times. Also, we want to have, when they enter 20 and they press return, we want to clear the text field, right? So we want to clear the text field when they press return. Let's do that first. So to clear the text field, you could simply say, here, anybody want to tell me how to clear the text field? Text field, remember text field has a text, right? I could simply say text field empty. Yeah, that basically clears the text field. You could also say nil here. So this is going to clear my text field if I run my app again. So here we dismiss the keyboard, we clear the text field, we check for the user's guess. And here, let's test this again. So I put in 20, I press return. It clears my text field. Everybody text field was able to get cleared? Was everybody text field able to get cleared? Right? I got an incorrect guess. Bad on me. Something else we want to do. So if I enter 20, which I entered already. Yes. Say that again. Where am I? Oh, sorry. Am I doing that reversely? Let's check user guest. Yeah. Good point. Thank you. So everybody saw that? So we had our text field getting cleared, then we call user guest. It passes as an empty string. The thing will always be wrong. So check the guesses first, then empty it. Thank you, sir. Run that again. So here I'm entering a guess. Let's add 21. Press return. Incorrect guess. 18. Correct guess. Good to go. Great. So let's keep going here. if I enter an incorrect guess, for example, if I enter 19 and I press return, I want the user to not be able to enter 19 again because they entered 19 before, right? So I want to restrict the user from entering an incorrect guess multiple times. They entered 19 already before. If they enter 19 again, I want to change my label to say guess was entered already. And also, I want to restrict them from entering the period, okay? So we have a couple things to do there. We could use, anybody has any clues as how we could attack this problem? Our last problem of the day. I want to restrict the user from entering multiple wrong guesses. So if I enter 17, I press return, the user should not be able to enter 17 again, right? Remember we started talking about the should check characters in range, right? That function here. Where is it? Should change characters in range. Everybody? Let me I'll give us some clues and then we'll go crazy with it. Right? So what we have to do here, let's go up to our check user guess. There's no more to-dos here, we're done with that. So we have a correct guess number here. The user entered a guess number. User entered a guess number, user input right here. Go back to your check user guess. We have a to-do here. Enter or keep track of entered guesses. How can we keep track of entered guesses? Very good. Anybody else? How can we keep track of the user guesses? What's that? It must remember it, but how?
When I press 8, like let's say I guess the number and it automatically like put it off. If I put another number in there, then it's like an add on to number 4. Because even if I put the number that was correct and I put a different number, when I put the correct number, it's still the same.
But we need a way to capture that. How? Yes? We need some data structure, right? Ahad was saying an array, Tanya is saying a dictionary. All those are data structures we could use. Everybody? We need some sort of data structure to capture that, right? For our purposes, we'll use a set, right? Because we know on set, we know the runtime of contains. What's the runtime of contains on set? .0, something there? Yeah. And writing that, we'll talk more about big O notation on Wednesday. It's a constant, right? It's constant time to look up an element in a set, as opposed to an array, which is linear time, right? So those are one of the big advantages of a set over an array. Constant time to look up using contains over an array, which has to go through each element. Everybody with me? Awesome. So here we've created a set here. So keep track of entered guesses using a set. All right, so you guys will create a property. You'll create a property called, so create a property called entered guesses. And it's of type set string. Cool? So create a property called entered guesses, and as the user gets here, they enter some input. You enter the guess here, right? So in here, you would say entered guesses dot insert user input So basically, your task is to get this line to work, line 36. Cool? That's step one in the process. User input in the string. No, no, no. It's on my app. User input in the string. So before user input. Okay, so we were tasked with creating an entered guesses property. We went up right below our guessing game model. That's a good place to create it. It's a variable, needs to be mutable. So here we have entered guesses. It's a set string, and it's empty, right? It starts off being empty. So here we have entered guesses on line 20. Keeps track of users' guesses. Cool? Great. So let's move down to here, our to-do. So on comment line 39, Did we not? Okay. Make sure this builds. So user input, we captured what the user entered on line 39. Great. So now we want to validate, as the user is typing, did they enter that guess already before? A good place to do the validation, let's take out that to do. A good place to do that validation is in the protocol method, in our delegate method called should, where is it? Right here. In should change characters in range, that's a good place to see, as the user is typing, did they enter that guess before? So that's a good place to do it. So let's go ahead and do it here. Again, we're all in should change characters in range. Right? Okay, cool. So let's get access to the text. Remember, the text is optional. The text field.text is optional. I want to get access to it. I'll use a guard statement. I'll say guard let text equal to text field dot text. So here I have access to the text. Remember, we said that current character the user is entering is the string, right? So I also want to get access to the string, right? So let's return false here. I want to get access to the string. So I'll create a variable or constant rather called current text. And current text needs to be currently what's in the text field. It needs to be currently what's in the text field and what the user just entered or about to enter. The thing the user is about to enter is that string argument here. That string argument here, that's what the user is about to enter, right? So current text becomes the text plus the string. And again, the string is coming from our function definition here. We have a string parameter here. That's the string I'm referring to. You sure? Which one, the string? So string is coming from that string is the one the user about to enter, or the one they're currently entering. It should probably call like current entered string or something, because at first you're like, what's that string? Like, what is that referring to? But the one the user is about to enter, that's the one that's currently on there. All right, cool. Let's keep going here. So now let's do some logic and test if the current text is in our, if that current text is in our entered guesses, right? So we have a set. It's called entered guesses. We could say that contains on it. That contains current text. And remember, contains on an array goes through the array linearly, every element. Worst case scenario, it needs to check every element in the array. On a set, it doesn't do that. It's constant time because a set is hashable. A set is hashable. The elements are unique, so I'm able to constantly find any element in that set with contains. That's why we made our data structure a set as opposed to an array. Okay? Yes, go ahead.
Why are we making current text equal to?
We need to combine them because the text field doesn't have all the characters.
Is that why if you do something like the string went down and the text field was blank, it would still be incorrect?
No, that's not why. So let's actually test it out, right? Let's test it out. Did everybody type out the entered guesses here? Did everybody type out the entered guesses? This block of code here. Let's test out what's happening with our should change characters in range. So let's put some print statements. So I'll put a print statement here. I'll put a print statement here. I'll put the first print statement. I will say text field. And I'll put in text field dot text here. And for the second one, I will put in string and I'll put in a string. For the purposes of debugging, let's see what happens. Everybody? The only way we could really investigate like what happens in a function is to test it. Unresolved text field, F. Right? The only way to investigate what's happening in any block of code, either use breakpoint or you could use a print statement to see what's happening as we're typing. Everybody? So here we want to see what's the difference between string and text field. Why are we adding them together? Tiffany? Right? So let's go ahead. Everybody type that out. Right? We're in the should change characters in range. Yes? Go ahead and run your code. Run, run, run. So in our text field, as it comes up, you can start typing. So I type in A. Well, let me get rid of the, actually it doesn't really matter. Let me change the keyboard. So I type in A, right? My text field doesn't have anything, but the string is A. Everybody sees that? Does everybody see that? I type in L, right? Look at that. You see the differences? Really pay attention to that. The text field has A, but string is L. So if you say text field.text, the thing you think you're getting is not what you're looking for. Everybody with me? Please pay attention to this. I typed in A. The text field was empty at that point. The current A was in the string that was about to get replaced or added to the text field. Everybody sees that? I typed in L. My text field only has A. It doesn't have L in it. Right? It doesn't have L in it. So that's why we need to combine them to see what's on screen. Like the actual thing that we see on screen here is not what the function sees in real time. So we need to add the text field's text and string to actually say, hey, is that thing you're about to type, is that part of my entered numbers or entered guesses? Right? Because we see it now. Let's go back again. Right? So I type in A. I type in A. Everybody, you typed in A. What happened? Your text field, what does it have? What's the current value? It's empty, correct? What's the current value of string? A. So if I say TextField.text, what's TextField.text? What's TextField.text here? It's empty, correct? Everybody. If I say TextField.text here, without adding my text and my string, what's the value of it? It's empty, right? If I type in L, what's TextField.text right now? A. So we have to combine them to get AL, because that's what's on screen currently. That's how the function works. The function works basically on every character that you enter. It has that current character, and the text field is not set yet, because you could still do validation there. So it gives us an opportunity to do validation, right? Like, do we want the user to continue, right? Okay, so that's like why we're doing the text plus string. Do we see that, right? So here, as we say text plus string, our text field would be AL, or our current text would be AL, like, right? So current text would be A plus L, right? So that would be AL like this. Everybody sees that? So we have to combine them to get to the logic we want. The method? The text field. Yeah. Unless it's pasted in, that particular function, yeah. So unless it's pasted in, we know it's one character. For that particular function especially, because that particular function gets called every character, for every character, not the other functions, right? For example, should return has the whole text field already. That's why our function is able to work. Cool? All right, good. So this is good. That showed us how should return really works. Let us keep going. So if entered guesses contains current text, what do we want to do here? we want to change our label. So what's our label called? It's called message label, right? Is it called message label? Message label.text, we could give it something. What we're going to say here? We'll say already guessed, that's good. Current text here. So we update our message label. And we'll empty out our input. Or we could just say text field. It's fine. Text field, because we only have one text field. So text field.text, we'll clear it. So this clears text field. And this here updates message label. Awesome, awesome, awesome. And here we're actually just going to return false, because at this point we don't want the user to keep typing. So return false prevents user from typing or editing text field. Something we could do too, we could also take text field, like really let the user know what's going on. We could say text field text color equal to red. So the user really gets like a visual cue, like, hey, the thing I did is totally wrong. Good point. Message label, thank you. Message label that text color equal to red. Thank you. So clears the text field here, updates the message label with a color, updates the message label's text, and returns false, so the user is not able to edit anymore. All right, and we return true at the bottom. Good. Yes, there are two returns. To check to see if that guess was yes. All right, let's test it out. See where we have bugs here. Okay, so our text field comes on screen. I enter 18. I press return. Of course, I'm going to guess on the first one. Anyway, I enter 19 or 18 again. And look, already guessed 18, right? Obviously, 18 was the correct choice, right? But for purposes of illustration, this works, right? The user entered 18 already before. They entered 18 again. It says you already guessed 18. Everybody with me? Ideally, you probably want to run your function again to get a new number. Everybody sees that. Ideally, maybe you want to return, like once the person gets a correct score, you want to change or get a new number again, a new winning number. But for the purposes of what we're after, this works. Let's run it again. No. We're still in the should change characters in range. So if you enter a number, let me return. What's happening? Why am I correct all the time? Let's see, 21. All right, enter 21 again. Right? Everybody sees that? Does it work for us? Does it work for all of us now? Right, it does? Okay, perfect. But we want to change that color for if. We want to change the color back to black. If it's correct, we only change it to red if it's already guessed. Everybody with me? So where we have our label again, let's go to our label right here. Just make that label black. Message label. that text color equal to black. So the only time we make it red is if the user guessed that previous number. Tiffany, does it still not work for you? Okay, so should begin. Let's try to get rid of this so you could get most things on screen. So the only thing we did for the validation was we checked our set to see if the current text exists, if it's inside of the entered guesses. But did you uncomment your entered guesses? That insert in your, what's that? You have to comment it out because it will be empty unless you insert the guesses. Let me show you. 1 second. 1 second. So let's go up to here. Right here. Where is it? Here. On line 38. Do you see line 38? Line 38. Tiffany? In the check user guesses. You want to add whatever the user entered into that set. Are you in the check user guess? So enter it. You need that. You need that insert there. Because if you don't insert, it's always going to be empty, and that statement will always be false. So yeah, yeah. A mini. Yeah, because it knows you're about to enter the wrong value. Yes, it checks every time. If you wanted to only check when you enter on return, you could take that logic into the should return. But if you want to check it as the user is typing, you keep it in the characters changing range. Cool? Very good. Everybody has the entered guesses dot insert. Yes, Andy? An error, like what kind of error? Oh, I got you. On which one? You have the entered guesses, Tanya? Tanya, did you get that? We declared it on line 22. All right. So we did a lot today, but we have a lot of power and functionality with using a delegate on the UITextField, right? If, as the user is typing, you could validate what the user is typing. When the user clicks on the return key, you could also capture what you want, what logic you want to happen there. And as I said, there's so many other functions on that protocol, on the UITextField protocol, on that particular protocol. There's many more methods, right? We might give you guys a lab to do today based on what we did today, but we're still specking that out. But we do have midday check-in talking about what we did today. Any questions before we move on? Any questions? We have it right when, after the user input, Tiffany. Right after user input, you might want to break up your logic. You may have had everything on one line, like which was fine for that particular case. Yeah, okay, cool. All right, so we will wrap up. Yes, Andy? All right, I'll come to you. So we'll wrap up today, and tomorrow we'll talk about big O notation.